If you were to place Betelgeuse where the Sun is, its size would cause it to stretch out beyond the orbit of Jupiter. Betelgeuse, a massive and unstable star, is destined to eventually explode. It is one of the most well-known sources of radio energy in the universe, emitting more energy than 1 billion suns combined. Betelgeuse, often called a red supergiant, has fascinated scientists for centuries. This star is so large that it can be seen from Earth, particularly in the winter sky. It marks the upper left shoulder of the Orion constellation. Although it's a star that is easily visible, Betelgeuse's brightness varies significantly, one of the key features that make it unique. In fact, stars are far more complex than the simple pinpricks of light we see from Earth. For example, while the nearest star is about 4.2 light-years away, Betelgeuse is much farther, around 600 light-years from Earth. Even if you traveled at the speed of light, it would take 600 years to reach it, which is far beyond our current technological capabilities. Betelgeuse's immense brightness is due to its size and power. It's about 10 to 20 times the mass of our Sun, and while other stars appear as tiny dots, Betelgeuse is large enough to be seen with the naked eye. This is because its radius is several hundred times that of the Sun. Unfortunately, there are no known planets orbiting Betelgeuse, which makes it difficult for scientists to measure its exact mass. The star's brightness fluctuates due to its unstable nature. It expands and contracts, causing its brightness to increase and decrease. This cycle can last anywhere from 10 to 100 days or longer. Betelgeuse also has large dark spots on its surface, which are caused by powerful magnetic fields. These spots cause the star to appear cooler in those areas compared to others. In fact, Betelgeuse's surface temperature is around 3,500 Kelvin, much lower than the Sun's. Betelgeuse wasn't always the red star we see today. It used to be yellowish, much like the Sun, but over the last several million years, it has slowly changed to its current red appearance. Scientists believe this change is an indicator that the star is nearing the end of its life and could soon go supernova. Betelgeuse is a star that produces significantly more energy than the Sun and would be a formidable competitor to our Sun if it were closer to Earth. Located about 600 light-years away in the Orion constellation, Betelgeuse is visible to the naked eye at night, which is particularly striking considering its distance. Our Sun is only 8.3 light-minutes away, which is why it appears so bright and powerful. If Betelgeuse were closer, it would be visible during the day as well. However, if it were to replace our Sun, it would likely destroy or displace Earth and the other planets in the solar system due to its immense size and energy output. Even if it were the same size as the Sun, Betelgeuse would still emit significantly more radiation. Betelgeuse, often referred to as the giant star, is a red supergiant that is about 600 light-years away from us. Its massive size is one of its most remarkable features. It is far larger than our Sun and could easily fit the orbit of Jupiter if placed at the center of our solar system. Due to its enormous size, Betelgeuse appears as a disk rather than just a point of light when viewed through telescopes, unlike most other stars. However, despite its vast size, Betelgeuse is not the largest star known. Its mass is estimated to be between 12 and 20 times that of the Sun, though there is some uncertainty in these measurements because calculating the mass of stars without companion objects to provide gravitational reference points is difficult. Nevertheless, even with its lower mass estimate, Betelgeuse remains an incredibly massive and luminous star. Its brightness fluctuates over time, varying between magnitude 0 and plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a plus 1 magnitude star. At its brightest, Betelgeuse can be several times more luminous than the Sun. These fluctuations are due to internal cycles within the star, causing it to expand and contract, making it appear more or less bright over time. Betelgeuse's surface temperature is relatively low for a star of its size, around 3,500 Kelvin, which gives it a distinct red color typical of red giant stars. Betelgeuse is nearing the end of its life cycle, having exhausted the hydrogen in its core and begun fusing heavier elements. This fusion process generates energy and causes the star to expand. Its atmosphere is full of complex phenomena, including dark magnetic spots on the surface where the magnetic field is stronger than in the surrounding regions. These spots inhibit heat convection, leading to cooler areas on the surface. Despite these cooler spots, Betelgeuse remains an enormous, brilliant star. Eventually, Betelgeuse will reach the end of its life in a spectacular explosion. As it runs out of fuel, it will undergo an extreme fusion process, turning heavier elements like helium and carbon. This will cause the star to expand, possibly becoming one of the largest stars in the night sky before it explodes in a supernova. A supernova is a powerful event that marks the death of a massive star and can instantly obliterate an entire solar system. The shock waves from this explosion could travel through space, and it's possible that Betelgeuse's end is approaching sooner than we expect. While this is not certain, astronomers are closely monitoring the star to learn more about stellar evolution and the fate of stars in the universe. As Betelgeuse nears the end of its life, astronomers are paying close attention to its behavior. The star is expected to eventually explode in a supernova, a catastrophic event that will send its outer layers into space, leaving behind a dense core. This core could either become a neutron star or collapse into a black hole, depending on the star's mass. A supernova is an intense event in a star's life cycle, signaling the final stages of its development. Given Betelgeuse's size and proximity, its explosion could be visible from Earth without a telescope. The explosion would release vast amounts of energy and produce heavy elements like iron and nickel, which are essential for the formation of planets and other celestial bodies. These elements would be spread across the universe, enriching the interstellar medium and contributing to the creation of new stars and planets. Recently, astronomers have observed unusual fluctuations in Betelgeuse's brightness, leading to speculation that it may be approaching the point of a supernova. While it is difficult to predict exactly when the star will explode, some scientists suggest that it could go supernova within the next 100,000 years, a brief moment in the universe's timeline but still too distant to pinpoint accurately. The James Webb Space Telescope, JWST, has provided new insights into the star's behavior, with its infrared capabilities allowing researchers to study the star's outer layers and magnetic fields in greater detail. These observations have confirmed Betelgeuse's ongoing changes, including its irregular brightness and potential instability. This research is helping astronomers better understand the processes leading to a star's death and the evolution of the universe. The eventual supernova of Betelgeuse will have significant implications for the universe. The shockwave from the explosion could potentially trigger the formation of new stars in the surrounding area, continuing the cycle of star birth and death. The components created by the explosion will spread across space, contributing to the building blocks of new planetary systems in the grand design of cosmic evolution. The death of Betelgeuse will mark not only the end of one of the largest stars visible to us, but it will also pave the way for the next generation of celestial bodies. Although we won't be around to witness the final moments of Betelgeuse, studying this star provides valuable insights into the life cycles of stars and the dynamic nature of the universe. Research on Betelgeuse helps astronomers better understand the processes that govern stellar birth, life, and death, and it offers a glimpse into the fate of other stars with similar characteristics. Scientists aim to continue studying Betelgeuse using advanced technologies and space observatories. The data gathered will continue to shape our understanding of astronomy, helping us unravel the mysteries of stellar evolution and the significance of their violent deaths in the grand scheme of the universe. As a massive and active star, Betelgeuse plays a crucial role in the cosmic puzzle, and its eventual demise will be one of the most fascinating events in the history of our universe. While Betelgeuse's death is inevitable, it's essential to remember that the universe is always changing and evolving. As the star nears the final stages of its life, astronomers continue to collect critical data on its behavior and potential supernova event. Studying such stars offers astronomers a rare opportunity to observe stellar death up close. The enormous release of energy during the supernova will illuminate the surrounding space for a brief period, allowing scientists to observe the complex processes involved in a star's demise. Additionally, the elements produced in a supernova, such as iron, carbon, and oxygen, are essential for the formation of planets and life. These elements will be spread throughout the universe by the shockwave, enriching the interstellar medium and providing the building blocks for new stars and planetary systems. This process is a vital part of the cycle of stellar birth, life, and death, contributing to the ongoing evolution of galaxies and planetary systems. One of the most intriguing aspects of studying stars like Betelgeuse is the insight it offers into the future of our own Sunday. While our Sun is much less massive and will have a different fate, studying massive stars like Betelgeuse helps scientists understand the potential outcomes for other stars in the universe. These findings shed light on the evolution of stellar populations and their development over cosmic time. Furthermore, Betelgeuse's eventual end will highlight the ever-changing nature of the universe. Although we won't witness this event in our lifetimes, the data collected from Betelgeuse will continue to influence scientific thought for generations to come. The study of such massive, evolving stars will remain a crucial part of astrophysical research, helping to unlock the mysteries of how stars live, die, and shape the universe. Examining the life cycles of stars like Betelgeuse also refines our understanding of the larger cosmic cycle, including the birth, life, and death of stars across the universe. By studying the final stages of evolution in massive stars, researchers gain insight not only into individual stars but also into broader cosmic patterns. This understanding is essential for the study of galaxy formation and evolution, as stars are fundamental building blocks in the development of galaxies over time. In addition to advancing astrophysical research, the study of Betelgeuse's potential supernova will provide a better understanding of the types of radiation and cosmic events that affect nearby star systems and even the intergalactic medium. When a star like Betelgeuse explodes in a supernova, the sheer force of the explosion can impact surrounding space, triggering the formation of new stars or disrupting the balance of neighboring star systems. The aftermath of the explosion has significant implications for the broader universe. The debris, including heavy elements, will spread across space, possibly influencing the creation of nearby nebulae and aiding in the formation of new planetary systems. This cosmic recycling process plays a crucial role in the ongoing evolution of galaxies and will shape the development of future star systems for billions of years.